We're gonna sit here and hang out for just a little while folks show up, and then we'll get started. I have Sweeney Todd stuck in my head. This is what Tiny Desk does to me, is get musicals and music stuck in my head. If you hear that leaking out, sorry about it. Hi everyone. We're gonna hang out just a couple more minutes. I'm getting started a little early. I was excited to stream today. So say hi in the chats, and I'll say hi back, and we'll get going here soon. Da, 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 da. We'll get everything arranged. Oh, that sound means that it's coming out of my speakers. Just switch it. Da, 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 da. All right. Hello, Beata. Thanks for stopping by. Okay, let me pause and pause this one. Hi, Sam. All right. Hello, everybody. Seems like you can see and hear me, which is great. This is Deep Dive. It's 2 hours or so of me just hanging out and doing some low-level CircuitPython work. CircuitPython is a version of Python designed for microcontrollers, which are little, inexpensive computers that kind of get used anywhere you need a little piece of code to do something for you. So CircuitPython brings the Python language to those small computers and makes it really easy to bring them to where you want and get started with programming Python on small devices. Here's one for example. So this is a Feather. Let me switch to, right now it's an eye tracking mode. So this is product showcase mode, and underneath this little shield here is a small microcontroller. This one does Bluetooth. It's a blue board, and the board is designed by Adafruit, who pays me to work on CircuitPython full time. So thanks to Adafruit, the folks on the stream as well. So this is a Feather nRF52840, and we're going to talk about Bluetooth Low Energy today. And that is kind of my test. One of the challenges with BLE is talking between the two. So that's my whole, hopefully it works just fine. Let me talk to something else that I'm working on board. Adafruit sponsors me to work on CircuitPython, and they make all these sorts of boards. You can go to adafruit.com, purchase hardware there, and support Adafruit and myself. So that would be super helpful if you would do that. If you have questions for me during this stream anytime, just feel free to drop them in the chats. We've got two chats going on here. We've got the bottom one is YouTube, and then the higher one, and it looks like looks just a little cut off. I wonder if the saying I'm missing just a little bit of it, and I forget how to adjust that. So sorry, Beata. We'll see you in just a minute. Show up on there. I have some margins that are cut off to try to get just the chat. But that's the YouTube chat for the stream, and then in the middle here we have Discord. Discord is a chat service, and the nice thing about it is that it exists kind of all week long. It doesn't just come and go with the live streams. So if you want to join that, you can go to the URL adafru.it/discord. That will get you on the Discord server for Adafruit. During the live stream, we're in live-broadcast-chat channel, but we also do have a CircuitPython dev channel as well if you want to follow along with CircuitPython developments. And with that, I've kind of figured I'd pick up where I'm at on BLE. So BLE is short for Bluetooth Low Energy. It's pretty much the only Bluetooth that you find now in more modern devices. Older devices will use Classic, Bluetooth Classic, but BLE is becoming more and more popular and getting more features. So all the new BLE stuff, Bluetooth stuff tends to be Bluetooth Low Energy. What I've been working on is the board that I showed is an NRF52840. NRF is Nordic Semiconductor, and RF is like the short term for it. I guess it's not an abbreviation necessarily. But it is really a, it was our first kind of like full BLE implementation in CircuitPython. So it's kind of our gold standard in terms of what we can support. And then we also have these others. Let's see, this is a bad example. This is an espressif chip. This is the S2, but the S2 is actually the only espressif chip right now that doesn't have BLE support. That's what makes it bad. But here's an S3 Feather, for example. So it looks very similar shaped, but this chip can not only do BLE, but it can also do Wi-Fi at the same time, which makes it just a little bit cooler. And so this is from espressif. And so we've had Wi-Fi support for a long time, but we haven't had BLE support. So I had done half the work and then discovered that it didn't have a feature that we definitely needed. One that the NRF stuff had, and we kind of like had designed our APIs around assuming that. But recently, relatively recently, the espressif engineers added support for that feature. And to be more specific, and I talked about this 2 weeks ago on my deep dive then, but we needed to be able to kind of like create servers. Randall asks, is the Nordic chip on the LED glasses controller? Yes, I think that is the same one. We can go to our desktop and look for Adafruit and LED glasses. Down by the sea. Driver board. Yep, NRF52840. So yep, that's the same chip as what I was the same as the Feather that I was showing. So we've had Wi-Fi support on the espressif chips for a long time. They support BLE, but we hadn't connected it up into CircuitPython, largely because the previous, or the API as it was in espressif, they have this thing called the IDF, and the IDF is the like software that the vendor provides to kind of go between the very low registers of the device and C code. It didn't have support for what I think of as dynamic servers. So I went in depth in this last week, or 2 weeks ago, but I don't really want to like super dig into it now. And I think it was at the start of the stream, so you should be able to find it. But basically, you say, I want to create this server, and it's this particular service and some data that goes along with that service. You used to have to know ahead of time what you wanted to be before you started making connections to folks. But in CircuitPython doesn't work that way, because we try to create our own services and then run, and then the user code can create services after BLE is already going. So they added the ability to do dynamic servers of services. Like you can either serve a service or be a client of a service. That sort of confusion there. So they added the ability in the IDF, and now I have a PR out that we're going to look at in just a moment that adds the ability in CircuitPython to create services dynamically. I think one of the key things that people want to do with this, for example, is that if you want to pretend to be a keyboard or a mouse over BLE, not Bluetooth, well, not Bluetooth Classic, but Bluetooth Low Energy, BLE, you have to create an HID service that the device that's connecting to you can read and get information about what's happening on the keyboard or the mouse. So I think one of the main things that people want to do with BLE is BLE HID, keyboard or mouse. And to do that, not only do we need this server stuff, but we also need a thing that we're going to talk about today called pairing and bonding, which my brain hasn't really thought much about. And in fact, it might be a case where I just don't want to get into it too much today and may punt it till next week. But yeah, so pairing is the process of taking a connection that is unencrypted and encrypting it. So doing some negotiation there. And you can protect. So when you're serving a service, services are a collection of characteristics, which are kind of like data, different types of data. And you can guard accesses to certain characteristics, and even, I think, maybe services too. Characteristics, at least, based on whether your connection is encrypted or not. So this is how you would get a keyboard that was not sending your keystrokes out to the world for anybody to listen to, but you establish an encrypted connection before you start sending keystrokes. So to do this HID use that I suspect most people want, we've got to not only have this BLE service stuff that I have a pull request for and we'll look at in just a sec, but the pairing and bonding that establishes encrypted connections between devices. Pairing is the process of establishing the encryption, and then bonding is remembering the state enough that you can kind of like automatically re-encrypt connections when you reconnect. So bonding is remembering things. hamslabs says, I just got a potential workaround for the esp-matter install issue on Mac. Nice. hamslabs has offered to try to give demos of Matter stuff, because another feature that many of the espressif chips have that we don't currently support in CircuitPython on anything is the Matter protocol, which has a bunch of different transport layers, but we really haven't dug into Matter too much yet. So that is something that's on our radar, and I kind of set it out a challenge 2 weeks ago, say like, hey, if you want us to support Matter in CircuitPython, what would you actually want to do? What is that like first project or first goal? In similar to like the BLE HID keyboard, what is the thing that you want to be able to do that you can't do today? So hamslabs has taken it on themselves to try to get that example going. So if you are also like hamslabs and want to see Matter support in CircuitPython, connect up with them on the Discord to work on that. Any questions? Oh. Okay, so the first thing let's do is let's start by Dan just got back to me on my pull request, so I actually just want to reply to him on it. So this is the pull request, add ESP BLE GATT server support. I've added Dan as a reviewer, and he's requested changes. We also have this long-standing issue for this work, January of 2022, and we've had like seven people chime in that they're excited for this. So it's a long time coming, almost 2 years. Mark says, I love that Matter is being worked on. Hopefully I have time to look at it one day soon. I am not working on it, to be clear. hamslabs is looking at it. But BLE is. BLE on espressif is getting better support. So yeah, let's just go over the questions that Dan had so I can get back to Dan before the day is done. So this is, I don't always show this side of code reviews, but I thought it'd be interesting. So I requested a review from Dan, and he's gotten back to me on feedback. Addressing the ports that don't work. So let's just reply to this first. bumps it further. So I had to update TinyUSB. I also added ESP32-C2 support. Espressif has a good reference. Their website's quite good. And you see they've announced the P4 and the H4, but right now these are unobtainium. I don't know how to get those, so I'm not actually working on them. Although you can see in the ESP-IDF, you can actually see more chips that they're working on adding support for. But the C2, so on the C series, there's this 2, 3, and 6. On the H2, they only actually list the H2. But I got myself a C2 dev board. You can see that it has Wi-Fi 4 and BLE. C3 has Wi-Fi 4 and BLE as well. So I as kind of a palette cleanser, I also added C2 support because I had done a DigiKey order and I got them. The C2 is a little confusing. It's not that interesting, and in fact, I couldn't get BLE fully working on it. It ran out of memory. It's got pretty small memory on it, and CircuitPython is not super memory efficient. I only was testing it with Wi-Fi on, so you probably can do Wi-Fi or BLE, but not both at the same time, memory-wise on the C2. And then the other confusing bit about the C2 is that the boards are also kind of called ESP-86-84s. I think I'm looking for my dev kit. I also got some C6 dev kits. Oh, and an S3 dev kit. Yes, but so if you want to test it, oh yeah, here it is. So this board here is the C2, but it's actually labeled ESP-86-84. Not super interesting, but it was kind of a palette cleanser, and I'm kind of a completionist. So I added CircuitPython support for the C2. But note that it doesn't have the RMT peripheral, which is what we use for neopixels. So it's got a status LED on the board, but it's actually PWM'd. It's not RMT. So it doesn't have a lot of support. It's just me being a completionist. And it does have BLE. Hi, Altayeth says, is the C2 basically a cheap 8266 replacement and presumably a chunk less flash and RAM compared to the C3? Yeah, that's my guess. My guess is that it's really just, it's just cost reduced. So vendors do this a lot, and sometimes when they do it, they don't actually make a new chip. They just don't tell you that it's got other stuff. I'm not sure what the case with the C2 is, but I think two of the ways that you end up getting, you can have problems with yields. So like if you have, you say you have 256K RAM, but you have actually like 16K banks. And like if some manufacturing problem happens, you may not be able to use one of them. So even though your silicon or your design is the same, you may not be able to use all of them, for example. So that can mean that you have like lower cost parts. That's a process called binning, I think. But then also, if something's really popular and you're going to buy a ton of them, you may actually, if you shrink what is on the chip, you actually reduce the size of the chip itself, which also saves money. So yeah, the C2 is kind of like the smallest, least capable of the C series. Why they released it, I don't really know, but I got a hold of a dev kit. So it's like, the ESP-IDF is quite good for CircuitPython to build on top of. So it's not too bad adding support for another one. The TinyUSB change came in that we now use TinyUSB on devices that don't have USB device support because we have USB host support over SPI. So anything with a SPI connection can actually do USB host using the Max chip. Anyway, that's why that's there. Could you add issues addressing the ports that don't work? So I just replied, Dan asked just some other questions I did not test. I'll put this and that don't work in the release notes. When this is merged, could you add issues addressing the ports that don't work? Thanks. And I don't know what he means by ports. I suspect he meant just points. But if you know me, I try to move pretty quickly and have folks test and find issues. So I fully expect that some folks will find issues. Dan asks, what is the use case for not always having BLE ext ADV? This is short for BLE extended advertising. Advertising is the process of just broadcasting to everyone. It is not encrypted. It's just a broadcast. And extended advertising is a feature of BLE 5, and the ESP32 doesn't have BLE 5, it has BLE 4. So that's the answer that I will give Dan here. So so BLE support is available on pretty much all of the ESP chips except for the S2. So ESP32, C2, C3, C6, S3, no S2. H2 as well. H2 is the first one that doesn't have Wi-Fi, which is also tricky and interesting. This says, does lib mesh have anything to do with ESP now support? What is lib WAPI for? Either does it have them available? Okay, so no actual changes here on the PR, just a couple of replies to Dan. Regarding the C2, probably no USB host. Size-wise, I must play with that USB host stuff more. It was amazing to see it load images to a large screen. Load images to a large screen. I don't know what that is. Is that somebody else's demo that I didn't see? Down by the sea. All right, and as always, if folks have questions, I'm happy to answer them. Otherwise, the other thing I was going to do is I want to start the bonding work, but that might just like break my brain on a Friday evening. Oh, okay. Dan must be around. Yeah, I fixed the ESP32 thing. So this might be kind of interesting. I finally realized what my issue yesterday on the ESP32 was. So I have this set up. I got this set up this week, which was using the NRF board to talk to one of the ESP boards to do some testing. Previously, I was testing from my phone, but the benefit of doing it from another CircuitPython device that I'm compiling means that I can actually turn on better debug logging, and we'll probably see this later, so that I can kind of see what's going on. And actually, I didn't realize it was the C6 that was hanging. The C6 worked from the NRF, so we'll see. I fully expect we'll find bugs. But the ESP32 was having this watchdog timeout. And I finally realized that I saw that there's a setting in the ESP-IDF where you can say use a high priority interrupt to drive the BLE stuff, the BLE controller. And that got me thinking like, like one thing that can stall interrupts is actually an interrupt that doesn't work correctly. So if you have an interrupt set and it's running, interrupts usually have to clear their own state that's causing them to happen. Which got me thinking like, oh, maybe what's happening is that I have the wrong interrupt handler running. And the way that that can happen is that there's this notion of weak functions in C. So you can provide an implementation of a function that basically gets overruled if something else is, if something else matches the same symbol, the same function. But that relies on the linker kind of like seeing it all and replacing one with the other. It doesn't fail if for some reason the actual implementation you need is not actually brought in. So I had to add this. I'll show you in here. I changed a lot of stuff here. I added the C2 stuff, but I also changed the defaults. So new C3, new 4 megabyte boards will no longer have OTA by default, which meant all of the old ones I had to explicitly say to enable OTA so that hopefully they don't change at all. So only new boards should do OTA, and the nice thing about, or should not have OTA, and if they don't have OTA, they have more space for features in CircuitPython. So 4 megabyte existing boards will not have BLE, new boards will, because they will not have OTA. So that's the trade-off there. What I had to do is, actually in the make file, I thought. But there's a kind of a weird way of this. So in the linker flags, I have to say, hey, look for this unknown symbol as well and include it. And it's a way to force it finding that object file that has the non-weak version of the interrupt handler, which is really weird. But that was why the ESP was hanging, is that we weren't linking in the right interrupt handler that actually cleared the interrupt. As a result, no other interrupts could run, and if no other interrupts can run, then the watchdog goes off. Okay, Tyeth responded to me on my question a while back, said no special demo, just me in the greenhouse playing with the TFT test code and SD cards versus USB versus flash load speed, plus switching to Adafruit image load rather than on-disk bitmap. Yep, image load will be faster if you have the RAM to store the image in RAM, for sure. Okay, so that's the state of it. Looks like it was merged. Dan merged it while we're on the stream here. So the absolute newest builds in CircuitPython that a few hours from now will have the BLE server stuff re-enabled and active on espressif stuff, which should be super exciting. So if you've done BLE before and you want to try it on ESP, please give it a shot. If you haven't done it before, try it on ESP still, if that's your jam. But pairing and bonding are also critical, and those are also not supported. So maybe let's just dabble in that a little bit. My fun Friday activity that I kind of want to pick up is, I don't know why I'm so yawny. Probably because I need more sleep, as always. I've ranted and ranted and ranted about build systems, and a little bit every night, which is why I'm tired, because I didn't go to sleep as early as I should have. I've been working on building CircuitPython using my own Python-based build system, build toolkit, almost. And I kind of wanted to poke at that and work on that some more, and maybe show it off a little bit on the stream too. So if that's interesting to you, maybe we'll like do a little bit of bonding stuff and then maybe get a demo going just to test. Sorry for the contagious yawning. Yeah, maybe it's because the window's open. I don't know. Maybe because it's Friday afternoon. Yeah, definitely a little sleepy. Anyway, get me animated talking about build systems. Maybe I'll wake up. I do kind of feel like I don't really want to dip into bonding yet, but I'm hoping it's really simple. And I did run across some example code that does the bonding related stuff. So I thought maybe I'd start there. And just see how far I can get. I think that's it. But yeah, I'll probably want to show the build stuff. I'm pretty happy with it. I have more work to do, but I'm generally happy with the approach. So let's do some bonding and then we'll do a little bit of build stuff at the end. Okay, so pairing and bonding is the process of taking a regular connection. So you've already established a connection, but you want to upgrade it. Carl says, laughing at sleep deprivation, a programmer might sleep on third day. Yeah, I mean, the other thing is I have a 2-year-old at home. Although, yeah, so you know what, I was thinking about this. This time of year, I just generally don't sleep that well. I sleep worse this time of year because I live in Seattle, and so the sun, as the days get real short, I just don't sleep as well. So like, I have I'll just show you. I have this CircuitPython powered weather display, and you can see it has, let's see, this is sunrise and sunset times. And that's just, let's see, like 5:27, is it 5:27 or 6? Yeah, 5:27 in the morning to 8:44 at night. So the nights aren't that long, which means that even if I am still asleep, I don't sleep as well. So this will go on for like 2 months, and then once the days get shorter again, I'll sleep better. Combine that with the fact that I have a toddler and a build system project that's keeping me entertained in the evening, leads to the yawning. Okay. So let's do some espressif stuff. So bonding is the act of remembering, and that should be the easy part. So, well, in theory. So the ESP-IDF uses the NVS partition on the ESP chips to store the information for bonding. I'm hoping that that's all done for me. But maybe what we need to do is find an example first so that we can test it. So let's look at, I think there's some stuff. I think I might have looked here. CircuitPython-manual has some example code. No BLE code. So the other place to look is in the BLE library. It's the bug of not being unbondable we had in a previous project. I definitely do feel like just doing the reason this build system stuff is like, my hobby coding is usually only Python. I think it gets me a little away from the hardware. Although I really would like to get back into the stemma G0 stuff, where I'm building, like, now that I have a build system I'm pretty interested in, I think it'd be really useful for building simple projects as well. Okay. So here's BLE. Let's look at examples. Let's see what we have. If we have any bonding. Let's just look at HID central. It's all commented out. Oops. This is probably because I changed it and never updated it. Hamslabs says, my sleep patterns are similar. The variation on length of the day here in Buffalo is similar to Seattle. Fortunately, I got a CPAP and I'm sleeping a lot better. Ah. Yeah, maybe I should look into that. Okay, so that's not filled out. I wonder, do any of these bond? I don't actually remember how to do pairing. Here we go. There is a way to just call bond. Oh, and connect. Device info service. Ah, here we go. So current time service is kind of neat because on iPhones, this is only on iPhones. I don't know if newer Androids have this. Maybe they do. I was thinking about getting a newer Android just because the new one, the new 8A is 7 years of support. I've got a 3A, but it's out of support. But iPhones have the ability to tell you what time it is using this current time service, but you have to be paired. So maybe we should just do this. So in connection, there's going to be a pair command. So we'll leave that open. Let's just give that a shot. So, and then we're going to look at ESP-IDF examples. And we're going to go examples, Bluetooth, nimble. There's BLE central and BLE peripheral. And let's try that. It works on the ESP32, C2, C3, C6, H2, S3. It also demonstrates security features of the nimble stack, like bonding flag, min in the middle protection flag, and secure connection only. Enabling link encryption can be configured through menu config options. Any BLE scanner app can be used for it. I'm not actually going to run the demo, but extended advertising. It's got to be on a chip specific thing because that's not supported on this ESP32. Let's see what this says. Main entry point. Store status callback. I wonder what that is. So it initializes NVS. SM bonding, R-key distribution. Secure connection. Let's just do that. Starts by initializing non-volatile storage. Allows us to save stuff in Flash. Carl says, as a programmer, I found I was the bug most of all the time. Beata says, I assumed it was a standard service, not a proprietary one. Current time service? I'm not sure. But when I did all the Nordic support, my Android phone did not provide it. It was only iOS that provided it. I don't know whether it's a standard service or not. We could look. The function pointers. Security man, the local input output command is to set to 3, which represents no input and no output. Ah. So that's something you have to tell. Okay. DJ Devin 3 says, one of my first BLE projects I did with the NRF50 was NRF52-H4 was pull a time from my iPhone. At the time I thought it was useless because I couldn't just look at the time on my phone instead. Now I realize how handy that can be for anything with time-related code. Works great on the iPhone that even a beginner, me at the time, could do it. Yes, this watch, my Anchor support email, runs an NRF52-H4 with CircuitPython on it. So it updates the time using the current time service. It's actually running a version of 8.0 that was like pre-release. I haven't updated it. It just runs. It can be set. Man in the middle protection. Which in turn necessitates protection against man during the pairing process. The flag can be configured through SDK config or menu config as mentioned above. Secure connection. I'm trying to remember, there's so much jargon, but I feel like we only support legacy pairing, if I remember right. And we definitely do want to be able to do that as well. Storage callbacks which handle read, write, and deletion of security material. Command line interface. We don't care about that. Peripheral advertisement is going to be the same. Advertising flags and transmitting power level. Setting the device name. We do actually want to do that. Okay. So let's just change our initialization. And I think instead of looking at the tutorial markdown, let's just go to the main code, and so we could actually follow it. So let's borrow it. Down by the sea. So the case that we're going to do is that the ESP is going to advertise. Phone's going to connect to it. The phone is going to connect to it, and then the device is going to initialize pairing, or is to initiate the pairing process. So that's what we're looking at here. So I closed all my windows because I wanted to start kind of anew. But we're going to go into BLE.io and then connection. And here's to-dos here. Phi update complete, connection update, L2 cap update, gap event. Advertise beyond and pair the initial initiate process. Get paired. To do, implement this. Okay. This is basically what I'm doing right now. Implement the thing that's marked implement this. Okay, so how does power control gap event encryption has changed. We probably want that. Gap event, repeat pairing. So this is all in gap event. So where's our gap events coming in here? First, I think what I want to do is I just want to start logging more. I'm going to start, my plan is to just start logging. Here's connection event. I don't actually know where that's used. Let's add some logging, and Copilot's on, and I've really started liking Copilot for this. So I can do ESP, that wasn't right. But then I can do static, and it gives me like something reasonable. For debug printing, all you need is something reasonable. So I'm just going to start logging all of our... See, so it gave me... I'm hitting tab and it's completing it all the way. So I really liked Copilot. It just makes my printf debugging faster, which is hilarious. But most of the time it like produces reasonable like debug prints. And I think I want to just... I kind of want to update all of these. I'm actually going to do this as a warning. No, that's not what I want. That wasn't... I think I want to be ambitious and try to like make this my last major work on ESP BLE. I'd like to move on to other stuff. I'm hopeful that it's not going to take too long. BLE can get complicated trying to juggle all the different services you want to tie into. Yes, BLE is complicated. It feels a bit over-engineered, but USB is similar, and the longer these things exist, the more you kind of know the golden path of like the way that people actually use the specs. So you don't have to be complete about it. You can just do the ones that are most relevant. Okay, so let's log here too. See, like, I was just like, I just want to log something. Let's do this too. I usually rip out all my logging before I make a PR. Oh, I need to make a new. And I'm actually just using all of the GitHub, the Copilot suggestions, because I don't actually care what I'm printing. I just kind of want to start seeing what I'm doing. And then I'm going to do what am I thinking? In adapter, when we start up, I want to do more of that. Config, the config here. So let's go to here. Yeah, see, there's all this. We're not going to do passkey because we don't do passkey stuff. But I'm wondering if we're going to get all of these authorized things. Generate a new non-resolvable private address. Oh, on sync. See, this is a great example of vendor SDKs where they're just like assuming that they're doing it at compile time. Whereas like we don't really do that at all. Addresses are a whole nother thing. Okay, so let's copy all of this. And let's go one by one. We could, in theory, I don't think we do SC at all. Let's maybe just look at our ducks to see. We do want to be able to do the IRK stuff. So you can, when you bond with some device, you can exchange information about how you're going to change your IDs over time. So you can take what looks like a random ID and kind of figure out who originally or who's producing it. It's like a way of like privately advertising, which we do support on Nordic, so we'll want to support here. I think that CircuitPython.org, BLE. Let's see what it says about security. Adapter, advertising. I think Dan did some bond or some stuff as well. So we'll want to do erase bonding. Here's the different types of addresses. Resolvable and not resolvable. Attributes. So these are attributes that you can have on characteristics. So like what level of I think LESC is the SC. I didn't know if we actually supported it, but I guess we could turn it on. Oh, I guess, yeah, characteristics have read permissions and write permissions. Characteristic buffer, BLE.io connection, connected paired, connection interval. So with Bluetooth Low Energy, you actually negotiate like how frequently you're going to talk to each other. That way you can go to sleep in between. So that's what this is. Pair. It does not say how. Scan entry UUID. Let's just say that SC works, and we'll change it otherwise. Now let's do. I'm just going to take this. So we don't have any I/O capabilities. This is used in, and maybe we could say, oh, we have a display, for example. Yeah, let's just see if that works. Let's do git switch C ESP BLE bonding as well. What was I? Okay, so we're going to start with the ESP32. Do 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 do. On my old iPhone 5 SE, if you had multiple identical devices connected, they all show up the same. On Android, you can rename them with custom-friendly names. Interesting. Last I checked, iOS still hadn't instituted friendly names. I don't know. Yeah, because there's an ID under the hood. We should be able to change it in CircuitPython, though. The gap process has a name, I think. There's another yawn, sorry. Is it the weekend yet? Oh, it generated the wrong thing. Connection 89. This is kind of why it's good to like keep it compiling pretty quick. That's why the tag didn't show. So it's cool, the clang D is adding this marker here to tell me the first thing that it give it is the tag. Like it's telling me the variable names. It's really handy. Loading the example code's kind of a pain. We'll do that over Wi-Fi. Maybe I should start with the S3 actually, because the S3 has a USB. That's usually the best place to start. Right. Sorry, I should have said that. Carl says they share their security keys on the encrypted link. Once the devices have paired, they can choose to bond. Bonding is the process where devices remember the security information exchanged during pairing. Yep. So you got to pair first, and then so you don't have to pair again, you bond. But I'm hopeful that the bonding side, the security saving side, will all be done for me by the ESP-IDF. That's my hope. And in fact, you know, after saying the S3 thing and being like, how do I load it? I'm just going to find an S3 to use. Let's start with that. I found an S3, but I want an S3. Here we go. I've added labels so I can see what it is. So this is an S3 N32R8, so it's got 8 megs of PS RAM on it. So it's a great one to start with because it's like not going to be constrained by anything. So I'm going to actually switch to that because that's just going to be easier to debug and load code onto and stuff. So I got to get my test code on there. Where's my... I have like so many USB cables here. Okay, so the setup I have here is this one is going to be the serial output. Which I think is actually Silicon Labs. So that's the serial output from the S3. And I'm going to split this one top to bottom, and this is going to be the CircuitPython output. So this is CircuitPython here. And then the way I usually do it is I have espressif ESP32-S3. Okay. I'm going to clean it, I'm going to rebuild, but I'm going to flash. So I manually press the buttons to get it into bootloader mode. Can't really do that for the cutie pie, too small to add a label. I think I did, but yeah, it's pretty small. The label definitely had to be truncated. So we're just getting things going. I probably won't get too far with this bonding stuff actually, because I kind of want to do the build stuff. Kind of want to show folks where I'm going with the build stuff. Does that interest? Is anybody listening that that's interesting for? If you build embedded C projects, but no Python, that's my target audience that I'm a member of. So yeah, we'll see how far I want to pull this thread for bonding before I give up. And Sam says, I'm kind of curious about the build stuff. Cool, I'll show it off. I don't know if I showed it off on the stream yet. I'll at least load the demo and kind of see if there's a... I kind of like to get myself into this like pull on this thread, pull on that thread sort of stuff. It's really hard to do Friday afternoon. Because I also like... DJ Devin 3 says, I'm interested in Honcho and Clang update. I know you're really interested in that stuff. Okay, so yeah, well, let's get the demo going and maybe we'll do like a round or two of getting that working. But then we'll switch to the build stuff. I've stopped using Honcho. I was heavily inspired by Honcho, but I also decided to not use it. It's like way more generic than what I need. That was the crux of it. The gist is that I want to just use Python to build to build CircuitPython. Python has API boundaries and you can refactor it, and yeah, a lot of nice properties. One thing I haven't added to the build stuff yet is the ability to know when not to rebuild something. So, which is kind of key to a build system, but right now I'm not worried about it. I want to get kind of like CircuitPython building completely, and then I can optimize how the build runs. Okay, so we're loading our new code. And now we're gonna hit reset. So we can see the debugging on the bottom right. The left should connect once it initializes. So now it's up, and I see it pop up in my So let's just do, I don't even know what the code.py in here right now is doing. So this is the packet buffer test. So I'm just going to duplicate, rename code PPS. Sure, why not? And then I have it pulled up. I thought the current time service. And let's just see if we could get that going. Do 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 do. Okay. I'm going to see if my phone sees it. I'm not just checking my text messages, which sometimes I do. Okay, here's CircuitPy. Okay, so we connected, paired. We saw our to-dos. I see it as fully connected, but it timed out in remote discovery. Okay. DJ Devin3 is excited for BLE on the S3. Yeah, it's gonna be cool. I was thinking about, well, that won't work, but having like an e-ink where I can show like notifications from my phone, that sort of thing, BLE's really good for. Okay, so if we just start pulling this thread, unhandled connection event 32 and 15, we can look at what those are, but I actually kind of want to see, how do we initiate pairing? I don't know if this example actually has it. I'm sure there's a way, and it's probably in, I think I could guess the name of the file. Control-P, BLE GATT.H, nimble host under IDF. Okay, let's look in here, and let's look for pair. Gap unpair. How do we initiate pairing? It's got to be right above here. Encryption initiate. Here we go. Pair initiate. Use gap security initiate instead. Okay. I don't know. Is there any mention of bonding here? Ty says, I was really surprised when my neighbor said his kids wouldn't be interested in CircuitPython devices unless they had Bluetooth and MP3. I was super thrilled at the time about web workflow. Won't be an MP3 player device because BLE isn't classic, but does open some potentials as MP3 controller with USB has so many neat things happening. Ty, do you mean audio over BLE? Because that is something we don't have yet. Bonding is restored. Okay, so there's no direct bonding. There's no bonding flag. Oh, you know what we should do? Let's find an example. So let's look for that in ESP-IDF examples. Proximity sensor. Central. Oh, CTS, that's probably current time service. But it's still central. Connection handle. I can nimble peripheral. Here's an issue. I believe that a peripheral can only request that pairing encryption be initiated. The central must initiate the procedure. With the peripheral, we can configure the various SM options. Let's see what they say. I call the security initiate from the gap connect event. No pairing is initiated in the characteristics configured. Okay. So that is the right way to go. And it should work on either one. All right, that's easy enough. I think the bonding information we're going to have to figure out. Look at that. Yeah. We don't need the to do anymore, but let's keep the printing there. And then what does it return? Not connected already. We usually have a check. Nimble there. Maybe that's right. And I wonder if we're supposed to wait. Do we wait for pairing to complete or not? I'm looking at the Nordic reference because that's kind of like the reference implementation almost. Yes. We wait. We wait. If we're not already waiting, then we initiate it and then we wait. Check security status. I don't know what that means. We may already be trying to pair if we just reconnected to a peer we're bonded with. So we might have to do this in the future, but I think for right now, let's just ignore it. Right now, let's just recompile and reload and see. What we should get is we should get more. Oh, I just had a good idea. I had another AI can help me moment. Do print at debugging, but let's do this. And then that can be the last thing I do here. So I had this idea that there's all these connection events and they're just the numbers, but AI would be really good at just like converting, like generating just a switch statement to print out which one it is, which would be really helpful. I don't know how to do GitHub Copilot. I could ask GitHub Copilot to do it, or I could just use ChatGPT. That could be really handy for this debugging. Connection event type. It doesn't know where it is. So I just searched for it. Trying to find the place it's defined. I probably should figure out how to change my clang D. Case. I'm looking for where it's defined. There it is. It's in BLE gap.h. Hey, look at that. BLE gap events. Okay. Copy. All right, let's do it. I'm going to just do it. I think I have to log in. So I'm going to do it off screen. Make sure I don't have anything suspicious. All right, so here's ChatGPT, and I'm going to say convert this to C code that ESP checks an error code value and ESP log eyes the name of the event. Error. Yes, yes. Congratulations, you're writing the same thing. Here we go. Oh, I like it. I like this really, this AI world. It's been really, yeah. The GitHub Copilot's been pretty good for that as well. I just need this switch statement. In fact, oh look, it made it a whole function for me. I'm just gonna copy that. I don't feel like, you know, some people are like, oh, I don't want it, like AI generated code. But I'm kind of the opinion of like, that just saved me time to write this code. Like there's not anything super novel about it. Like it's really just converted. Okay, so let's flash it again. No previous prototype. Yeah, this is the sort of thing you get into it here. Oh, it needs to be static. Like I've had with my like generated printf debugging, it can be like, oh, you used the wrong you used the wrong like % character for the data type, that sort of thing too. I've used OpenAI recently. Ask you to do print debugging, it will, but then the next thing you'll ask you to do is, no, please use debug print with F strings. It always seems to default to non-F strings. Mark says, I tried ChatGPT today to convert a CSV to SQL inserts. Yeah, I could do it by hand, but saved me tons of time. Did it write the script to do the inserts to like parse the CSV, or did it just give you a big long dump? DJ Devon3 says, I've stopped giving ChatGPT attribution because anything I give it with copyright headers, it immediately strips out. Huh, I haven't seen that. I mostly use it for printf debugging, so I don't really care. Like, I'm going to delete that code before I commit it anyway. But I'm also kind of of the opinion of, like, code is not that novel. Necessarily novel. Okay, so we added the ability to print out. I also added the ability to actually start the pairing process. There we go. Nice. Phi update complete. We called pair. Event subscribe. It doesn't look like pairing actually did anything. It did answer the question of like it doesn't seem like it. Okay, this is something separate. We're not using that. Gap event MTU. That would be interesting just from the perspective of like we want to know the MTU. Data length change and MTU. So that's something I could stub out too. But I don't see any actually like pairing related stuff. Unfortunately. Disconnect. I wonder what that disconnect reason is. I guess it's because when it raised an exception, it disconnected. Piata says they want you to use proper typing style, no caps lock, and always use the shift key on the other side. Hamslabs says NetBSD just banned AI generated code in their project. I believe it's for copyright and other IP issues. Yeah. That's kind of where what I was alluding to is like, I've been just generating this stuff. Like, I don't really care. Hamslabs says I use ChatGPT to generate an example for handling an RGB LED using esp-matter SDK. I haven't tested it yet. Oh, Timon says it looks like some of the connection parameter handshaking was unhandled. Oh, so that might be why pairing didn't work? Perhaps. That's a good point. Maybe I should do that first. But I'm rapidly approaching, I'm just going to commit this and then push it and do the build stuff. Hi, FedA2. I think that's where I'm at. I'm ready to switch over to the build stuff. Anybody else want me to work on this? This stuff is what I should do first. I think Timon is right about that. All right, I'm going to do build stuff because I want to. So this stuff compiles. Stage. Yeah. We're going to say git status. Start on pairing. Add logging. Oh, they would not understand each other then. Oh, right, because I set the different settings for things, and maybe the host is already doing some of that. which would explain why I'm timing out on service discovery. Yeah, interesting. Good point. I'll do all that next week. I am here all week next week. Should be able to get it going. Okay, so I pushed that, and now I'm going to do git fetch init. And I'm doing this in the Nordic one, although I'm going to switch to Raspberry Pi, and I'm going to switch to embedded build, which is my name for my branch that I'm doing that work in, and then it's Python. Build CircuitPython-v, and this should crash. Yeah. Okay, so now I need to do a new tab. Sorry, I just making sure I know where it is. I gotta clone it here. TinyUSB embedded. Oh, that's what I thought it was. TinyUSB embedded. Committed 16 hours ago. Git clone. TinyUSB. Maybe I did show this. Did I do flit? Externally managed. Oh, source. Okay. So I've installed it into the virtual environment that this one should be. Color log. I don't have my, there we go. And it crashed. Which is what I expect. But did it crash where it crashed? And I wanted to hide this. Async IO exceptions are really, really ugly. Okay, so this is saying we have a callback to undeclared. And yes, I generally work on this on my laptop, which is why I had to clone the embedded build stuff. But so it's logging. I gave it -v, so it's logging all the stuff. So I've got it doing all of the QStore build for CircuitPython. And then it's starting to compile the files for its actual output. But it's getting some errors because one thing I'm trying to do with this rethink is I'm trying to whittle down the pound defines or the command line defines that we give. So that's why this is complaining that we're not, that the CircuitPy device is not defined, is because the build script is not giving it to the file that expects to have it. And I kind of want to I don't want to give it to all the files. I really want to start being more specific about the command line flags that we use for building things. One thing I want to show that I'm kind of excited about is that there's this UI.perfetto. And if I open CircuitPython, I now have a trace.json that I can drag to this UI. And I don't care. Googlers only, nice. So what this is this is So my code in my embedded build library. So there's two pieces to this. There's new Python files that define how to build CircuitPython, and then there's kind of like this embedded build toolkit under the hood that is doing some like basic providing some building blocks for the build. So I have it kind of right now always logging, always doing this trace logging, so we can actually see the steps that the build is going through. So one thing I'm finding is that, you know, when people talk build systems, they always think that they have to be these like declarative things. But what I'm finding is that it's actually like really nice to reason about this as a script. So you can say like, oh, it does this, and then this, and then this, and then it's done. Let me show you what I mean by that. So we're going to just ignore these files that are open for this stuff I should be working on. And now we have a build CircuitPython file. And it's converted from the Honcho stuff, but it is not Honcho. So we have this board. So this is kind of like, and I'm rethinking how to structure it. That's one thing that's nice about using Python, is that you can actually structure the different components and how you build them. So this is like the top level for CircuitPython. So a board calls the port, and the port calls the top level one. And this is similar to the way that my Honcho was structured. And then I'm wrapping it. If you call this directly, I have this embedded module is my like build toolkit thing, and you can call embedded CLI run build CircuitPython, and then it tries to intelligently provide command line options based on the function that you've given it. So if we do --help, you can see that it wants a list of boards positionally, and then there's some like standard flags for being a build system, kind of, right? So like, how many jobs do you want to run at once? Do you want to do debug locking or just verbose logging? And then help all. This is arg parse into the hood. But this is actually the build toolkit's dynamically generating these based on the parameters that the function you gave it have, which I think is kind of clever. So in lib, there's also this picolibc.py, and so this is how you would build picolibc. Now, I can either call this build function, which is what I'm doing from build CircuitPython, or you can call it directly and you'll get a CLI for it. So this is something that I've wanted, in that I want to like be able to test each individual piece. So if I do build lib picolibc, now I get this different options. I get, okay, what build directory do you want? Give me your CPU or your MCU, and that's how it figures out the like compiler that it's going to be targeting. And that's automatically done by the fact that the build function takes in a CPU and a compiler about it and a build directory. So this CLI run is doing that magic. And you can see here that I had this test function that allows me to, was allowing me to build picolibc twice. And then this is just for when I want to do compiler RT, which I haven't done yet. So that's kind of part of what is cool about this system, is that it's Python, and therefore you can structure your build process like Python. Now, the way that you get, one thing that you get for free, usually with build systems like Make or Ninja, is you get parallelism. And the way that this is getting parallelism is through asyncio in Python, not CircuitPython, regular Python. So what you'll see is that when you want to do something, you're doing asyncio functions at the top level, So I could build 2 boards concurrently by just doing those 2 separate tasks. And then 2, within this, I can do, well, I'm building my version header the same, and then I'm awaiting the Pico build, because the Pico is like your C library, so you got to do that first. So if we go back to our chart, we're doing our header generation, which took 124 milliseconds, and then we're doing picolibc, which is taking a while, 2 seconds, and then 2 seconds again. Yeah, the auto-generated help idea seems like it helps to cut down on boilerplate. Yeah, so if we look at, if I add folder to project, and I do, sorry, repos embedded, if we look at how this is implemented, so now we have CLI, and we have this run, and you give it a function, you do arg parse, and then you look at the signature of the function that you were given. And if it's a CPU, you say this. If you need a CPU, you also give the option of giving the MCU, and then you can figure, based on the MCU, you can know what CPU it is generally. And then if it's a path, if it's a list of strings, and then you could add more stuff here. Simone says, I do think it makes sense to see build systems as scripts. I don't quite understand the build systems shouldn't be Turing complete crowd. I agree, especially because I see a lot of people, a lot of build systems calling out to Python code, right? So like you lose your purity argument if you have to call out to a script anyway. And then in this rant that I had a few weeks ago, you also like tend to see people wrap their build system in Python anyway. Anyway, so this is also setting up like the color logging, and then it does argument conversion, and then it actually just uses async IO to run the function. Now, run eager. Oh yeah, make sure that we set it as an eager task factory, which is a async IO detail. And then I actually was like wanting it to, like, you get this like giant junk of errors exception. So it uses async IO exceptions to like halt the build when it fails, which actually turns out to still like necessarily run multiple things, which is kind of silly. But yeah, that try except that's commented out would hide all this stuff. So what the only thing you'd actually see is this. Now, I got to figure out how to manage that, because sometimes when you're writing the scripts, you actually do want to see your Python exceptions, which is why it's commented out. But yeah, so I added this like basic trace stuff so we can see how long these are taking, and then it keeps track of how many. The other core piece that makes this kind of like a build tool is that in this build file, there's this run command. So it takes a command. You can optionally give it a description and a working directory. Caller directory is a special thing where the function, it captures the directory of the function that calls this function, and uses it as a default for working directory if it's not set. And then all of the paths, so command is a list of either strings or paths, and if it's a path, it expects it to be an absolute path, but it shortens it by making it relative to the directory that it's going to run the command in. And then you have to call this a init thing, because this is how you limit the number of jobs that are running concurrently, is that you have this like with the shared semaphore, and then we have this notion of like which tracks or threads are available. That just makes like multiple things show up on the same line. And then we subprocess it out, and as we do that, other jobs the Python script can continue running while this happens. And we track the time, and then this is the trace entry that is actually what we're seeing here. And then we say, oh, if it returns just okay, we'll log the description as info and debug. Otherwise, if it's an error, we'll kind of like log everything at different warning levels, and then we'll raise an exception. So that's kind of like the core piece that kind of makes this a build system. And I'm imagining I'm going to add things like, you know, skipping tasks if the result would be the same or it's already been done. But I haven't done that yet. So it's running. One thing you'll see is that when we run this again, this step will be shorter because Ninja's doing that under the hood for us for PicoLibC. This reconfigure still is a while, so like we'll have to figure that out. And then here what we can see is that this is all the QStir pre-processing, but there's a bit of a like bottleneck in terms of like when it collects them all together. And then what we're starting to see is it's just starting to compile everything, and then it stops the first exception that it gets. So that's, oh, and you can't see it. Sorry. Let me make my window slightly smaller so you can see what I'm talking about. Okay, so this is threads 0 through 31. I have 16 core, 2 thread per core machine. So it automatically figured that out. And so we're being very not parallel. Sequential at the start, we do version header generation, which we actually could do concurrently with the PicoLibC stuff. And we could actually, maybe we should change our script to do that. And then what we can do is, and then it does QString preprocessing. It does collection of QStir stuff to generate the final headers. And then the final headers are used by basically all of the files that you compile. So that's why there's a bit of a bottleneck. So that bottleneck appears in, it's like kind of written in code, which is not a bad thing, I think. It's way more explicit than what you would see, what it would be implicit in our make files, but here it's explicit, which I think is a good thing. So right now we're doing, we do run command to make the header file, and we run the command to run the PicoLibC process. Let's just parallelize this while I'm at it. Okay, so we're going to take this async task group thing. So task groups make sure that if one fails, the others get canceled. It's not super reliable at doing that. But what you can do is you can, instead of doing await, you do tg create task. And then you run it. You do the same thing. So one thing that really threw me off is that when you call an async function, it doesn't even begin to run it. It just wraps it in something that you can run later. And I think here we do tg create task. And I think we have to, if we want the equivalent of this, to get the results, we have to, I don't think that will work, because create task is not going to yield us. I think what we have to do is we have to do results, which is a little unfortunate. When we await, you get the thing that's resulted. Yeah. Timon says, Zig build system follows the same philosophy, by the way. You just write Zig code to define your builds. Somebody pointed that to me, and then I decided I didn't want to write Zig. Like, I'm not writing Zig, so I don't really benefit from that. One thing I want to steal from the Zig stuff that I looked at, though, as well, is that they say, oh, you want to build this thing? Well, here's how you just tell it what to fetch for the source code. So I actually was thinking, like, in this embedded build toolkit or whatever, like, I'll actually include this PicoLibC code to build PicoLibC, and the first thing it can do is fetch the source code, right? And then, like, then you don't have to worry about it. I think PicoLibC task. results. I think it's just results. Sure. Okay, so what this should do is this should run the version creation and the PicoLibC build concurrently. So let's do the build again. And like I said, we're going to build everything, but it was quicker because PicoLibC didn't actually have to build. And now I can load this into Firefox again. I think if I just drag and drop it. Supporting argument inspiration. All right, it should have been faster than that. It's got a local cache key in there. Let's get rid of that. Maybe my file's not valid. There we go. There. Okay, so we see a couple things, and this is like, I added this and I'm like, this is super helpful. This is super helpful because like all of the printf debugging is like, or all the print logging is really like kind of hard to comb through. And this is really what is interesting to me. So now I can see that I'm doing both the header creation and the bit of PicoLibC. So PicoLibC is all like Ninja here is only taking 13 milliseconds because it doesn't need to rebuild. And I want to add a thing to like, oh, we don't actually need to reconfigure either, and that will shrink the build time. But what I'm trying to do is I'm trying to get to the point where where I have a full CircuitPython build going, and then I'll just add things to, figure out how to make it faster, right? So like, oh, like all these things can have this policy in terms of like, I don't need to pre-process a file if it hasn't changed, right? And how do you figure out it hasn't changed is another thing. And now we can see that the compilation is here. So there's kind of a bottleneck here, but that's a bottleneck that already exists in the make files as well. Because I think we generally say that like the headers that these generate are dependencies of everything else. So yeah, that's kind of where I'm at, is like, I just need to change some of this stuff. And in fact, I think this is I switched CircuitPy-USB to CircuitPy-USB device in the build, so that might actually fix it. So this is all the logic that like we kind of have equivalent logic for in make files already, except for the fact that you now do it in Python, which is way better in my opinion than doing it in C. So I wonder if I can find that. So I'm not deleting the make files. My goal is to have this like alongside of it. But then you can do things like, oh, for these things, add these arguments. Like you can do much more higher level constructs. And you can do like globs of files. So I just want to build all of this directory. This is not right. Flash file system is external. That sort of thing. I had a problem building CircuitPython, which I haven't tackled yet, which is why I cannot find an ARM compiler for RISC-V, so I'll have to build something. I'd like to test that on my 64-core RISC-V box just to see how nice it works. Hey, if you have Clang, part of the reason that I'm doing all this work is because I want to switch us to using Clang instead of the ARM GCC compiler. So in here, there's a compiler.py, and it has two options, although Clang is the one that we use by default. And then in build CircuitPython, actually, I guess I do pass in a compiler to board. But I'm just saying board.build. Okay, so board.build So this is figuring out how to, it's importing ports.boards.board name. So I had to add dunder inits, but I actually, so in ports, Raspberry Pi, boards, this is the only board I've done, but now there's an init.py. Oh, and there's this rogue picolibc directory. So this would replace the mp-config board.make file. So you can see these are kind of the equivalents. So you're giving USB vendor ID, product name, manufacturer, chip variant, chip family, and flash devices. Here's how you would do that in Python, right? And there's this little weird thing of like the board ID comes from the folder name. So that's the way to do it kind of properly. So it's calling the ports. So from ports, import Raspberry Pi board, and we're awaiting that. So this is all async stuff. And then in the port, we have an init.py. It has an async board. No, it's adding port flags. And it's adding all these include paths. And actually, you know what? I should port flags. I can make a list. Port flags. And then what I can do, these are the ones I care about the most. So instead of making it all a string, I can not make it a string and instead make it a tuple of two things. I could also yeah, this is definitely a rabbit hole, but I also like it. So what I'm seeing here is that I'm doing the same thing 3 times, right? So I could do a for base dir in, and then do this, and it's actually port dir SDK source. So I just want common RP2040 and RP2 common. Now I'm going to do this thing. Let's not use this one. Let's use the second one. Base dir. And now I'm going to extend it, and I'm going to just do isystem. So strings get left okay, and then directories will get relative to the working directory. I love the way the code looks. Thank you. It's like the CircuitPython build is complicated, but I'd much rather complicate it in Python than in makefiles. So here, extend. These ones should be okay. And then I am going to have to change build CircuitPython. So now I have to flatten it. It doesn't auto flatten. So port flags here, I'm going to say is now a list. Port flags. And I don't know where, there's port flags here. And what you can do is you can do star, and that will unpack it. And we're going to have to unpack it here too. Here and here. Here. And it's just Python code, so I could like make it better. So let's run it again and see what we have. Okay, so we still failed. We're getting isystem POSIX paths. So that is not right. So This can happen if it hasn't been, yeah, so like, here's a big long chunk of string. Like somewhere here, there's, yeah, there's a list that shouldn't be a list. Clang E, so this is the pre-process step. So I must have missed a port flags. There it is. So like for these sorts of things, like we could make, like the async IO exception handling is really confusing. Like the fact that it's giving me all these runtime errors, like it's actually running a bunch of stuff, and I really just want it, like I wanted it to be when you fail the first time, that's all it does, but like you get all this junk. But here's actually a build failure. Undeclared function. And then this is called the undeclared function tud-ready. So this might be that we're like not including the right thing. But I think that's good. I think I'll commit that and go from there. We didn't change, did we change embedded build at all? No. So if you want to try this, this is something I've actually been meaning to do, is like I want to add some basic examples. And the stemma G0 stuff like really dovetails nicely in this, of like making really simple like one script C files that you can build for different boards. And cross-compile and stuff. Yeah, so check out that, it's github.com/chan/embedded. That's what's meant to be like the shared build machinery. And then most of the work I'm doing right now is actually in the machinery for CircuitPython, which is a good sign, I think. It's really just converting all of that logic that's in makefiles into Python code. Async Python code, but Python code nonetheless. You know, so I'll have to figure out like, okay, why isn't this getting the right thing? And I suspect it's around the fact that I haven't updated my build scripts. Like it's based on the Honcho stuff, and I changed the way that the USB stuff is managed in the makefiles. So I suspect that's my problem. The other cool thing that I wanted to show, well, just comment on, is because it's makefiles, or because it's Python now, I can actually do some way more smart things around modules. So I don't need to, like, every time I add a module, I don't need to do like, oh, CircuitPy underscore the module name is like this thing that gets piped through, and here are the sources that apply to it, blah, blah, blah. I can actually write code to just say like, okay, like what are all the modules in the shared bindings directory? So what are all the folder names in shared bindings directory? And I'll automatically convert that to CircuitPy underscore module name. So this is add global flags for defines used in np configs. So these are things that we need everywhere. So ones and zeros. But then when I'm doing, let's see, so this is, the Qster stuff is complicated. Pre-process and split DES. More approachable to make files. Yeah, pilot errors were long. Not sure if I like the name in the sense that if you search for embedded Python build, it will take years to get to the right link. Yeah, I'm open to naming suggestions. I really wanted to be pip install embedded and do, I think I bought the domain embedded.build. But yeah, I'm open to suggestions. I was thinking like toolkit or things like that too. DJ Devon3 says, I don't really understand it, but it seems like you're making the builds to be more modular and more efficient. Yes, so more modular is a goal. Easier to refactor and understand what's going on is a goal. One thing is like having API boundaries. So like, what are all the knobs that you can twiddle for how MicroPython, like the core builds? And there's like a little bit of an example here of that, of like the way that we call out to pklibc and have settings there. The other goal of mine is to be able to do concurrency across boards. And the way that I've been thinking about it right now is that you do async task group, build these two boards concurrently. And then what would happen is that you might actually want to build, like, if those both boards are M0 pluses, you may need pklibc built for Cortex M0 Plus twice. So the build system should actually be able to say, like, it's called memoization in programming, where you call the same function twice with the same parameters. So instead of doing it twice, you do it once. And you save a bunch of time doing that. So one thing to add that I have not added is this ability to say, like, I did two calls and now they're both calling. They're not actually calling the same thing. They're calling the same thing twice with the same arguments. One of them is going to happen before the other one. So the first time you call it, actually do it. The second time you call it, just return back the task for the first one. Anyway, so that's one thing I want to be able to do as well, is like, I want a better reason about how the build process actually works. And I also want to be able to build multiple boards concurrently. And if I can reason about the way things work and refactor it in a way that it can actually share work across boards as well, would be really cool. But I can't really do any of that until I'm to the point where I can actually build it. So that's what I'm doing, a little bit of that every day, as long as I'm interested in it. Yeah. So that's kind of like, between that and the fact that it's all Python, and I'm also learning async IO, which is something that I've wanted to do for a while. Cheers, hamslabs. Thanks. Yeah, I'm wrapping up, I promise. Another last thing I wanted to show is just how I did queusters. I actually have, it's all async IO Python, so I actually like combined async, or the queustering process, into sub functions, so that like they kind of get factored out and organized better. So yeah, if you want to check this out, you can do github.com/chanute/CircuitPython, and then embedded build is the branch that has this in there. It's all in the public if you want to know more, and then it's chanute/embedded for the build library that's underneath. That's like making sure that you don't try to do it all at once. Kind of serializing to that point. Anyway, let's commit the stuff, and then if folks have questions, now's the time. Otherwise, I'm going to get out of here. Build CircuitPython and ports, Raspberry Pi, init. Make port flags a link. A list. And then again, it will have reformatted it for me. Push chanute. Better build. Yeah, let me know what you think. That's like, this is where my brain's been, and I'm pretty happy with it, but it's just a slog converting all of the make logic over to Python. And then it's interesting to see how long it takes to run, and the trace output is just so nice. So nice to understanding how to make it more efficient. So I'll get to that point as well. I pushed it. I'm up to date, so now when I go to my laptop tonight, I'll have all of the latest stuff. I need to try it on a much smaller project as well. That is definitely on my radar. Okay, I think that's all. Todd asks, can I ask about Fona? You can try, but I've never worked with the Fona. I'll wait. I know there's a little bit of delay, so I'll procrastinate just a little bit longer. What I would recommend, as I'm waiting to hear back from you, is going to the Discord server. So the Discord's above me. You can go to adafru.it/discord, and you can ask the question there. There's help with channels. So there's like an IoT channel, or I think there's a radio channel as well. That's a better place to get help. If it's a Adafruit product, there's Adafruit support forums that you can go to. Forums.adafruit.com, I think is what it is. That's the place to get official. I'm just looking it up off screen. Yeah, forums.adafruit.com are our official tech support forums for us. Cool. So this has been a deep dive with Scott. Thank you all. Thanks to Foamy Guy, I should say, for doing deep dive last week. I was on a road trip with my dad, had a lot of fun. I should be here next week as well, even though it's a long weekend. I'll think about it. If you do want to know, check the Discord server. We have a deep divers role. I'm at TanNewt on Discord. If you want to have the deep divers role, let me know. Sometimes if I'm like bailing on it, I'll at them at that role so that you can find out. If you want to support me, do it by supporting Adafruit. They pay me to work on CircuitPython. They pay me to stream. They give me this audience. It's awesome. Thanks for everyone. You can go to adafruit.com, purchase hardware there. If you are like not in the US, there are resellers can be good. Resellers can be good if you're in the US as well. Adafruit still does make money if you buy from a reseller. They just don't make as much money. DigiKey is an example of that. Yeah, I think that's it. Join the Discord. Love to hear more about build systems or BLE and bonding. I'm going to get my brain back into pairing and bonding mode next week. So hopefully by the end of the next week, I'll be a lot further through all of that. Let me just read the chat and then we'll be out of here. It's a bit of a parallel thing my friend is wrestling with regarding wanting Python build configs for SymPy, a math library. It's all a little detached from me, having never used Meson or Ninja. In anger, only occasional tweaks to make files. I was mentioning Honcho to him. Yeah, I think, so Honcho is the thing that gave me the idea just to do async Python. But they don't quite do it the same. Like I'm leaning more into that. I'm leaning more into the Python side of Python than Honcho does. Last I looked, Meson likes to compare itself to Python, but Meson generates other stuff, which is fine, especially if you want like IDE interoperability. Like Meson will generate Ninja for you, and that was one route I was thinking I would go for a long time, is Python to Ninja. And Ninja does all of that like manage not rebuilding everything stuff, which is really, really handy, and I'm not doing right now. But Honcho was just like, why do that when async IO can do all of this concurrently for us anyway? So I think I agree with that principle of it. So we'll see. We'll see how it goes. I like my ability to reason about the build process much better. So my mode is that it looks promising. It will not be as fast as the other thing, but some of the stuff we could do to speed up the CircuitPython build is like structural that might be easier with a Python file that you can reason about. Anyway, it's a lot harder to reason about in Makefile or something that like does all of these steps. The step ordering is implicit rather than explicit. Anyway, thanks all. Take a look at embedded. Maybe I can extend it for building patches for Linux distribution. Yeah, I mean, it's pretty basic. The thing I would say is that it's not necessarily for embedded yet. There's going to be, like, I imagine there's going to be kind of libraries and stuff for that. But it's designed to not assume the CPU that you're targeting, which a lot of stuff for for like host systems, assume you're building for itself. Whereas like the CPU stuff I'm doing is like, I give it an MCU or give it, it could, if it's not a micro, that's fine. But like the idea is that you like upfront say what system you're building for, which may or may not work in a Linux application world. But the idea, like the core idea of being able to just use async IO, it's really, there's not a lot to it. It's just async IO with this like run command under the hood that's doing the basics of like logging and like constraining to make sure that you're not running too many commands all at once. But yeah, take a look at it. We could either adapt it or just do something similar. Have a great weekend, Mark. Thank you all. All right, I'm gonna get out of here. I'm gonna have a snack, get out of here. There's a parade tonight that I can't forget about. Well, I don't want to forget about. There's the clouds. Clouds outside my window. All right, have a great weekend, everybody. I will talk with you on Discord